The goal here is I want to try to take your demo application that you've created with Claude Code, add evals on top so that it performs much better over time, and make it consistent and reliable. All these agents become so good it can build whatever you want in your head. Like you can take any SaaS and just clone it. Then what is your moat? Training your agent backwards is completely overloaded and BS. There's really only 3 things you can do. Okay, so again, I just want to give you a 5-minute introduction into the exercise that we're going to be doing. Most AI apps are just demos. They have perfect prompts and controlled data. That's not how the world actually works. There's chaos, there's edge cases, and there's scale that you always have to worry about. And so you have all these builders coming into the market, and they're amazing. I love what they're doing, right? You can build anything what you can think of with Replit, with Lovable, with Base 44. But how do you take it so 1 million people can use the thing over and over again, and it becomes more and more reliable?
You're probably wondering, why is he wearing this hat? I'll tell you why. I'm in New York City. It's like 30 degrees. I don't want to freeze my you-know-what off, but this isn't about me. It's about you. You have given us your time watching this video, and we wanted to make it as easy as possible for you. So we turned this whole episode into a playbook on our website. Just click on the link in the description, and you can get the whole playbook with prompts, with steps, all the details you need to apply this to your work. Check it out.
Reliability is the production bar. I want everybody to keep this in mind, that when you're building out your chatbot, when you're building out your agent, when you're building out your eval system, reliability is key. Your system should work the same over and over again, no matter how much pressure or usage it is hit with. So what is an eval? Somebody asked us in the chat when we got started. It's a repeatable test that tests your AI system in a systematic way. It's a deterministic check or a score associated with the performance of that system. And it's a safety net that you can establish to ensure your system is performing the same way. Let me give you an example. Let's say you've created a chatbot where you're creating a travel agent that is booking hotels for you. Well, the repeatable test would be, is it booking the right hotel depending on the request that comes in from the user? A deterministic check would be that if we sent the same request over 100 times, how many times did it book the right hotel? And this safety net would be this test that we run periodically over and over again to ensure that that value doesn't drift. An eval is all 3 of these things put together across many different form factors and many different structures. Our goal here is that we're testing all the things that could potentially go wrong so that your system is reliable and deterministic as much as it can be. Now, software engineering has kind of solved this already, where we have these test suites and we would run these test suites in our CI/CD pipeline, and the CI/CD pipeline would tell us if everything was passing, if everything was working. Well, this is the same for AI and AI systems. Evals measure outcomes and the actual process. So people are asking in the chat, like, when do you know where there should be an eval? How do you know where to place an eval? Well, you want to have an eval that is end-to-end at the end, making sure you have like a user-facing eval saying, hey, this actually worked or did it. But you also want to have evals in the process or the steps that it takes for the system to actually generate something. So if you're retrieving something, that might be an eval. If you're checking something, that might be an eval. If you're generating something, that might be an eval. So as an engineer or even a product manager, you want to have the end-to-end eval and the evals in between.
One question here, just so I understand, like, to the example you gave a minute ago about like booking a hotel.
Yeah.
To me, that is pretty, like, it's pretty black and white, whether the job was done properly. Like the right hotel was booked or it was not booked. Do evals also work for things that are more subjective in nature? So let's just say we at 10X built an agent that takes all of our conversations that we have as a team, and it there's this ingestion engine, and it creates content for us. That basically is a content engine for the organization and for each of our engineers. That is subjective in nature, right? Like whether a piece of content is good to the engineer who's posting it from their Twitter is up to them, their taste, whether they think it sounds like them. Can you do evals on something like that, or can it only be done on something that's purely objective?
No, you can 100% run an eval on something subjective like that. Here's how. You have a human being that can judge the input output of something like that, right? Alex, if you look at the ingestion across 10X and you say that I want to pull all the Slack messages between me and Arman, and I want to grab our thought process on what 2026 H1 goals look like, well, you can grab all that information, see all the retrieved information, and then see the generated output. So even if it is subjective in nature, we can have like a sort of a rubric, which I'll show in just a second. Or we can have a human, like subject matter expert like you or Arman come in and say, hey, this actually performed the way it was supposed to perform. It retrieved the right information. It generated out something that is usable. and it sort of performed the task that we're looking for. So you can take that subjective thing and sort of break it down into different areas. So for me, production is pressure and repetition. So every time we build this application, whether we're vibe coding it or not, the thing that you should always think about is pressure and repetition. If I did this a million times over, would it perform the same exact way over and over again? And that is what true production mode means. What evals let you do is you build your AI system, you measure how well it performs, then you can fix certain things based on that performance, whether that's updating a prompt, whether that's changing a tool call, whether that's changing out the model that is actually being used, whether that's using reinforcement learning or deciding that, hey, maybe we should fine tune our own model. All of this should be done based on deterministic scores that you've sort of ran over and over again across your system. Once you do this, you can repeat this iteration cycle over and over again. Today, here's what we're going to do. I've built an agent called Ask Acme. Now, if you've used any of the component libraries for React, you know what Acme is. It's your really famous fake company. This fake company today that I've built for you is going to have an orchestrator agent that can have vector search, run SQL queries, or hit MCP tools. And the thought process of this is, imagine you had a second brain for your company and had all the knowledge across many different fragmented sources. You can do a vector search across all your documents, like your SOPs or your API documents. You can build a SQL query and do a SQL query on top of your Postgres database, or you can use an MCP tool on top of Jira or Slack. This is something that is very common type of system that everybody tries to build, and it's going to be sort of the starting point that we build together using the repo I've shared. Again, this is like your second brain, right? So you can add evals across all the decisions being made. You're going to have evals across all the different scenarios that may be coming in by job type. And we're going to see if we're able to build out a system that is more robust than just that generic first demo. Now, why is this perfect? The reason I've chosen this example is because I wanted to give you examples across multiple decisions that the agent could make. So you can go to SQL, you can go to vector search, or you can go to the MCPs. I want to showcase the evals on top of retrieval. That's people don't think about, like when you're actually retrieving those vectors and trying to do similarity search. And then finally, I want to showcase the multi-tool aspect of this, how you can have multiple things going on at once and see what could go wrong. And this is the maturity we're going to sort of walk through. I'll do the environment setup. We'll seed some data, build the agent. This is all done for you, and you can use Claude Code right on top of it. And then I'll walk through the process of stage 1 through 5 and the actual creation of the evals. All right. Any questions so far in the chat?
So just a few things that we've gotten, just maybe to keep top of mind. Matt said the answer to Alex's question sounded like a human doing the quote unquote quality check eval and not an automated system. I might have misunderstood. Could you elaborate on ways to have the AI eval the subjective output and its limitations? I think what they're basically saying is at scale, it's not realistic for me to do kind of all of the evals. Can you automate subjective evals?
Yes. So what happens is you want to calibrate the AI to the human for the eval. So I'll give you an example of this. We built an AI tutor. The AI tutor basically had a rubric that we created based on accuracy, based on completeness, groundedness, so on and so forth. At first, it was our teachers and our professors that would come in and grade it based on all the different categories. Then we had an LLM coming in to check and see the input-output pairs, but we would calibrate the LLM to the human scores and grades. So the goal would be that the grade that the human was going to give was equivalent to the grade that the AI was going to give. When you reach that point in calibration, then you can sort of say, okay, I'm going to automate this entire system and have the LLM start grading across multiple different records. So the thought process here is you have to sort of build up to that. You have to have the human annotate the SME come in and actually say, hey, this is good, this is bad, so on and so forth. Use that information to then automate the AI. Does that make sense?
Awesome. Yeah, that's great.
Was there more questions?
I think that's good for now. I think once you actually build kind of the eval system, there's going to be questions around like someone asked, how do you make sure your evals are not impacting performance as the system scales? And also, how often should you check evals in a production system? Since with LLMs, they could be generating new content every minute, for example. So feel free to take those questions if and when it makes sense. But those are like kind of once you've implemented the system.
Okay, sounds good. So cool. For those who are following along live, you can sort of grab the repo and clone it directly. Whether you're super technical or not, you can ask Claude Code or Cursor to run a lot of these different folders for you. What I've done is I've not set up this repo in a traditional software sense. What I've done is I've taken each aspect or stage in my thought process and put it in a specific directory. So whether it's a setup, whether it's an environment, whether it's seating, whether it's actually the harnesses, what I'm doing is I'm walking you through the process by which I would go and add more maturity to my evals. To start off, you just have to have Docker desktop running in the background to set up the initial agent. So if you have not downloaded that, make sure you do so. You're going to go in here, and I have this document that says start here, which has all the commands you have to actually run. If you tell Claude Code, it can also run all the commands directly. But essentially, all you're doing is you're going to walk into the setup within the environment, and you're going to compose your Docker containers, which have your vector database through MongoDB and a sort of Postgres database that you can use for your SQL search. And so
Sorry, if I could just jump in, looking at this is gorgeous. This is like the most beautiful tutorial setup for everybody. And like, it's no wonder you guys teach people how to use AI for a living. But I just want everyone to realize, like, this is a completely scaffolded project. Whether you're sitting back and just watching right now or later on, you can rewatch and go through it. This is literally like, Ash, you set up a step-by-step tutorial for everybody. And I just think like taking a step back to realize that they can follow along right now, whether you're technical and you want to do it right now because you already have familiarity with these tools, that's great. But if you don't, you can come back later. You can use Claude Code to explain every part of this to you with the video up next to you. And you can use this, even if you're non-technical, to get caught up right after watching this, right?
Yeah, 100%. And I've gone as far as creating Python notebooks in each of the stages. So if you want to actually walk through like my thought process, you can do so within the notebooks. So I wanted to make this as like ingestible as possible. And there's no way, over the entire 30, 40 minutes, I'm able to cover everything. But if you take this open source project and just walk through it, you'll learn at least the first 5 stages.
There's a lot of Ash fanboys in the chat. Just want to give you your flowers. But one thing before we hop into this, because I think we're gonna get very in the weeds of this, which I think is really valuable. But I just want you to reiterate, because you talked about like what evals are. You started this conversation by sharing like, how do we take something from MVP, like you vibe coded a lovable app, or something that you're non-technical, you built this app that works for you and maybe a few friends, and you want to get it to production. Just like reiterate for people, especially in like a business context or an enterprise context, why evals are so incredibly important to be able to use AI in a company context.
Yeah. So I can talk about the different hiring partners that we work with, or even in our corporate training settings. Nobody cares if your demo works once. Like, that's not the point. Like, who cares if it's able to answer 3 or 4 questions here and there? Is it actually moving the needle in terms of ROI for the business? So every time, whether it's in our corporate training or with one of our hiring partners, the question I always get is, yeah, this is all cool, but like when we go to production, what do we need to do? And production means that you can have 18 different versions of the same question, but it performs the same way. You can have 10,000 people interacting with your eval set, with your AI system, and it's always going to perform and be successful. And the goal with evals is, how do I give you a systematic approach to ensure you're headed towards that production value enterprise system? When I think of agents in the ecosystem right now, I think of Manus, I think of Cursor, I think of Claude Code. If you want to build something at that level, then evals are necessary, because you need insight into what's going wrong. You need insight into how to actually implement and change different aspects of your system configuration to make things better. And you need to do this over and over again over, let's say, weeks, months, and years. I think people are afraid, like, what happens with software engineers and product managers and so on and so forth. I think evals become the crux of what we're trying to do. We do a ton of code review. We do a ton of evaluation on a lot of these agents, and we make sure that these systems perform at a high scale.
Absolutely. And just to add to that, I would say that a lot of the clients that we talk to at 10X, like the big thing is companies want to leverage AI within their organizations because they know the leverage it can create for them. But there's like one word that makes them fearful, which is trust. Can we trust that this technology is going to behave in the way we want it to behave? And also that the cost of failure of it not behaving that way won't be insurmountable. So to your point, like this at its core is like trying to solve the problem of trust at scale for companies using this technology.
We know what's actually crazy. Like if you think about a world where all these agents become so good, it could build whatever you want in your head. Like you can take any SaaS and just clone it. Then what is your moat? Your moat is any data you have that is specific to you, or it's your eval set that makes your system way more reliable than anybody else. So I really think evals are the skill. Like if you're an engineer right now, go and learn evals.
Love it. Sweet. Let's fire it up.
Okay. I just created the environment. If you haven't used UV before, all I'm doing is setting up all the libraries necessary for our agent here. Again, what I've done is I've used LangGraph on top of some other MCPs. The MCP connection is just the dummy connection. We're not actually going to hit any real Jira or Slack instance. I wanted this entire thing to be containerized so I can show you guys end to end what's going on. So I'm just going to seed this entire thing. And you'll notice that I'm actually trying to seed this with synthetic data that sort of reflects what a real company would have. It's not at the scale a real company would have, but it does mimic what's happening. I've also tried to put really nice logging for your Claude Code or Cursor or whatever you're using, so you can use those logs as context for the next steps to take. In this scenario, our MongoDB vector database has like a pricing strategy, a roadmap for 2025, our remote work policy, different incidents reporting on-call handbook, different documents that a fake company might have. Our Postgres database has 26 customers in it, different refund policies, different transactions, and different more employee information. And then I have two fake MCPs with a Jira with like 8 tickets and a Slack with like 23 messages. At this point, you're ready to build out your agent. So all you have to do is go back out, and we can go into our directory called Set Up the Agent. You'll notice that because this is a learning environment, all you're really doing is going from directory to directory to directory to set up the tutorial. And then as you walk through the tutorial, it'll walk through the creation of the evals. Okay. And then inside of the agent and inside of each of the stages, I have a couple of things here for you. One is a Python notebook. So if you want like a real nice breakdown of what's going on, and you don't want to just it kind of running in the terminal, but like you want my thought process, what I've been saying, so on and so forth, like the different tidbits of information, then the notebook will walk you through that in like a very slow pace. If you're more technical, you kind of understand what's already going on, you just want to kind of run everything, then you can just run the Python files directly. For this, I'm going to run the notebook just to showcase what's happening.
Yeah, and so just as you're doing this for the non-technical folks that are watching, like myself, what exactly is happening right now? So you're running this Python notebook. What is that actually doing in practice?
Yeah, so what's happening is it's taking what I've just built, which is the agent with the vector search, the SQL query search, and the 2 MCPs, and it's creating this demo environment where you can try out different questions. So here, what I've done is I've created just a containerized version of a notebook where you can see all the different searches it can do, all the different questions it can ask, and you can actually edit this and run it live. So if I were to just run all the cells, okay, so here you'll notice that I give an example of the vector search our little orchestrator can do. And you'll notice I put a little source here so you can see where that information is coming from. You'll notice the SQL search it's able to do. You'll notice that it's able to go into your Jira tickets. You'll notice that it's able to go into your Slack conversations. You'll notice that it's able to actually do multi-tool queries. So if I needed to grab something from the vector store and I need to grab something from SQL, I could do so automatically. So this is just to showcase the Ask Acme agent that we're going to sort of start off with. This is your demo. Like, this is the thing you see on Twitter where people are sort of going through all their fragmented pieces of information and showcasing to you guys. Imagine if all your information was in one place and you can talk to your company second brain. Well, Ash just created that in like 15 minutes. So what's the point now? It's kind of working, right? No, it's not working, and I'll show you why. We're going to start off by creating the first eval, which is called golden sets. So a golden set is going to be 30 test cases that your product manager, your team identifies that you run your entire system through to see if they're actually performing at the level they should. To run the golden set on this repo, all you're going to do is close off this notebook. You're going to go outside and you're going to go into the stage 1 notebook for the golden set.
I love the sound effects that I'm getting when you run a command. I feel like I'm in a game right now.
Well, I was going to turn them off, and then I was like, actually, it kind of strays.
It's kind of fun. And so just so I know, like where we are now is basically you set up all of these different like databases that are effectively data sources that kind of fuel the second brain. So that's your vector DB, it's your Postgres DB, it's your MCP, so your connection to other applications. So these are all of like basically the octopus tentacles to all of your knowledge. You then in this Jupyter notebook are basically showing all examples of the commands you can run with the agent to query information from these different sources. And it's showing you what are example answers to those questions. So that's gotten us to a place of like in one place, seeing how the agent performs in providing information. And so from your perspective, the next step is like actually making sure that the answers are satisfactory based on the 30 most important queries that we could be asking this agent.
That's correct. It's the baseline we've established with the actual first version of the agent. Now I'm going to run that golden set eval, and we're going to see on top of that eval how much of it is actually working and what's not working. We assume that because we've created these connections, everything's working fine, but that's not always the case. So if I were to run this one more time, and again, I'm going to show in this video the notebook environments, but if you want to just run everything in your terminal, you just have to run the Python instead of the notebook. And each of the walkthrough files are essentially walking you through my thought process when establishing this eval. So this is the first stage, and I like to call it golden sets. So what are actual golden sets? You might be thinking that, Ash, you're just talking about input-output pairs. I've seen that before. That's not true. Each time you have an input-output pair, you also have these associated metadata that you might have to think about. It's constraints or checkpoints you want to put on each sort of input-output object. So for example, here, what I've done is in traditional software, we have like, hey, this assertion that this much must equal X, Y, and Z. In an AI system, you have a query, and then you have all the things that you must check off. Hey, if the PTO policy is mentioned, they must mention 15 days. They must mention an annual increase in value. They must do semantic search or add constraints to that semantic search. So you're not only putting constraints on the topics that are covered or the keywords that are covered, but also the tools that are being called. So in this scenario, if I were to walk you through where golden sets fit, it's the first stage. Like if I have been given an AI system and somebody tells me, hey, Ash, go and build out the evals for this. This is the first thing I do. I'm going to figure out 30 test cases with product managers, internal stakeholders, subject matter experts, sometimes even external users. I'm going to say, what are the most common questions you're going to be asking? Then I'm going to annotate each one of these test scenarios. The expected tool I predict that this question should ask is the vector search tool. The expected tool that this should use is going to be the SQL query tool. It must contain the following keywords in its answer, and it must have the following format or flow of answer. I'm going to actually run that agent over and over again. I'm going to capture that trace on my choice of an observability platform, and I'm going to run these checks manually with a human being. People always think that, hey, evals need to start off with like everything being LLM as a judge. I disagree. You need to be in the weeds of your AI system. Your product manager should be the one checking things off. You as the AI engineer should be the one checking things off. You as the subject matter expert should be the one checking things off in the beginning of that system. So in this scenario, I'm just going to run all the cells.
As you're running it, one thing I'm curious about is like you're building out all these evals.
Yeah.
Where where are the evals, or like I almost viewed it as like this rubric of like rules or criteria. Is that almost being stored in like a large markdown file that's being fed to the agent? Like, how is the agent referring back to the evals you've done?
So right now, I'm not storing the evals anywhere specific besides my local environment. So it's usually an MD file, or it's in the terminal itself, or it's in a YAML file, which I really like. Over time, as we get to stage 3 or 4, we can move towards just storing everything inside of our observability platform. So just move everything to LangSmith, LangFuse, Datadog, whatever you use, and make sure everything's in one place. Okay, so just to walk through this rather quickly, again, you can run this on your own and walk through each of these. In each of my test cases, I have an ID associated with it. I have the initial query, the expected tools that are going to be used, the expected sources that are going to be used, the keywords or the phrases that it must contain, and then the things that it should not contain or the things that it should not refer to. So as I'm creating this is my first golden record in my golden set, which is I have my initial query of what is our remote work policy. I have the expected tool usage, and I have the expected sources. I can run that through the same agent that we've created before, and I can see what goes wrong and what works out. So in this scenario, you'll notice that it ran the correct tool, it did the correct sources, it had the correct content, and it didn't have the negative check was also true. Some of these are deterministic values. Like I already know the tool calls being made. I don't need to send that to an LLM. Some of these can be done by a human being that is annotating it, or it can be done by an LLM that is annotating it. To start off, for this example, I just had a LLM do it for us, so it could be done quickly. But in most cases, a human being would be the one that is annotating this live.
2 quick things. One, can you just make sure you share your window, just so that's the full screen? The second is, one thing I'm wondering as you go through these golden cases is like, who's involved in this process? Because, for example, like I'm even thinking about like, say you're working on a vertical specific agent and say it's like a legal agent. And so there's knowledge that the subject matter expert needs to provide in the evals, but like the lawyer isn't going to necessarily know whether a vector DB should be used or whether like this MCP should be used. So like, who do you involve in the eval process to make sure like all of the key criteria are checked off by the person who knows what the right answer is?
Yeah, this is a good question. I think it sort of ebbs and flows based on the organization itself, but definitely the engineer who's implementing the eval, definitely usually some sort of product person. It could be the product manager themselves, or it could be even like somebody non-technical who's involved in the process. I love having SMEs on board. I think experts on board, boots on the ground, when they've seen all the responses back and forth, are required for you to annotate anything at all. So those 3 are mandatory. Everybody else you can add based on what you think is need based. But in my head, a product person, an engineering person, and an expert. Cool. Is there more questions that I missed? Because I'm not looking at the chat windows. Okay, cool.
No, I think you're all good right now.
Okay. So once I've done that check, I'm going to do that check over and over again for my entire suite of golden set, right? I'm going to walk through all of those 30, 50, however many I have, and make sure that every time I ship a new version of production, I run that one more time. So this is something that AI engineers in their local environment should be running before they send something to staging or dev, right? So you know, hey, the expected performance of what I'm shipping is the expected performance it was before. Now, that was a question somebody asked earlier. Now, when I'm running this test case, it could be on every commit. It could be before every deployment. It could be off after every big change. But the thought process here is run it as many times as you can, record it in a very simple location. It could be within the repository itself. That's how you start out. Don't add complexity where the complexity is not required, and just have a running log of what's happening. So that's going to be the first stage of evals, golden sets.
Awesome. And one other thing before we move on to the next set is, let's just say you go through an eval, you go through this golden set of 30 questions, and there's an unsatisfactory response to one of the questions. And so you want to correct the agent. What is, and if you plan on covering this, all good, but like, what is the process of actually like correcting the agent and making sure it behaves in the right way moving forward?
Okay, there's only three ways. Okay, there's this term, training your agent backwards, that's completely overloaded and BS. There's really only three things you can do: update a prompt, update a tool call, update the descriptor associated with the tool, or change the model itself that is making the decision. Now, there's reinforcement learning and fine tuning, but you'll find that fine tuning is way too expensive and not worth it. Reinforcement learning requires annotated and labeled data. So oftentimes that's probably not worth it or possible either. So at the end of the day, all you're going to be doing is updating a prompt, updating a tool, or updating a model. So I just want to say that out loud. Like when I talk about configurations, when I talk about iteration, it is always going to be one of those three things.
Love it.
And let's go to the next part. Any questions yet? Okay, back to my cursor here. I'm going to close this off. And the next part of our eval stages.
Ash,
yeah.
Sorry, a question just came in that I think is interesting. I wanna hear your thoughts on it.
Yeah.
Kieran just asked, is fine tuning on synthetic data a horrible idea? I know this is a detour, and Alex is going to yell at me because we're on a clock right now. But I'm curious to hear your thoughts.
I actually don't think it's a bad idea. So one of our professors.
Really?
Yeah. One of our professors at Gauntlet generates HIPAA compliant synthetic data for medical or clinical use cases. And he's the one in charge of our fine tuning class as well. I actually think it's okay to use synthetic data for fine tuning in very specific scenarios where it's hard to get data that is labeled in real scenarios.
Yeah, but isn't there the discussion of like collapse? Right? Like everything collapses towards the same thing being said over and over. And just so everyone understands what that means, like if you ask ChatGPT to tell you a joke 100 times, it'll tell you like 5 jokes. Like the model is a probabilistic thing. And
maybe it's just not that funny of a model.
Like basically the training data in the way that the model is configured, it's like, let's say it's a bell curve, like 5 jokes really fall in the middle of that bell curve, if you will. And the issue is if you're training on everything in the bell curve, everything will collapse towards that. Right. So that's kind of my take, but admittedly, I've never tried it. So yeah, I'm curious. What do you think?
Well, so I see where you're coming from, and I see the possibility of that happening. But if you, the approach they actually...
Here's where Ash shits on my life. Go ahead.
Not at all. Not at all. I want everyone to know that using synthetic data for fine tuning most likely is not even worth it because it's going to be too expensive. But in like, for example, in the HIPAA compliant medical clinical space, what they're actually doing is having human beings generate like the first 3 or 4 versions of it. They bring the variation in and you just sort of fill in the rest. Does that make sense? Like you're not actually doing any novel creation of data. Rather, you're just creating duplicate cases across many different categories. And so you're able to actually fill in the number of records required for fine tuning because it's going to be in the millions, right? And so in that, I guess 1 or 2 scenarios that I can think of, I think it's worth it.
Okay. All right. Alex, where are we at with the clock, by the way?
We have roughly 20 minutes left. How are we doing, Ash?
20 minutes left.
Okay, so I'm probably not going to get to the end of this, but I'm going to try to get up until the replay harness because I think for most people, if you get that far, you're doing a really good job. But we started at...
So do you guys have a hard out at 5?
I don't. Austen, do you?
I may or may not need to check in with someone, but I'm less important than you.
Okay. So honestly, I think people just from the comments and just the fact that basically no one has dropped from the live stream, like 0 people have dropped. I think people are really loving this. So let's just keep going as long as you're having fun and you don't have to leave for a meeting and people are enjoying.
Yeah, I can keep going. I mean, I taught like 3 classes today, so this is amazing.
Love it. If you really want to hit the deadline, you can just run a Claude Code job with Ralph and it'll get done in 10 minutes, the whole thing.
Okay, run everything step by step.
Okay. Yeah, do not fail.
Okay, well, basically, by the way, this is a tip for anybody who's less technical. Have Claude Code read the README per directory. It'll know exactly what to do because I essentially gave the directions for step by step. Okay, I'm going to go a little bit faster, see how much more I can cover. We're going to go into the second stage of this, which is labeled scenarios. So we created a golden set And that golden set was 30, 50, 60, 70 records of the most commonly asked questions. One of the key things that happens in a lot of these AI systems is that you couple the prompt or the query with the actual, different steps that system is taking so deeply that it's only able to sort of handle the golden set. And then when you start deviating from the golden set, all of a sudden your whole entire program goes to shit. So in this scenario, what we're doing is we're taking different categories that might be asked by our users, creating golden sets by category, and then categorizing the performance of those based on our eval across each of those categories. So let me show you what that looks like. And I feel like, Alex, when I typing in the terminal, feel free to just shoot me a question and I can answer it.
Yeah, for sure. As you're doing this, basically what I'm understanding is you are increasing the total database of potential queries and potential answers. Like you're just providing more guidance on what this rubric of answers is by kind of having a golden set for several categories within the agent, right?
Yeah, and I'm basically making sure that everything's annotated and labeled so that I can use it in the future.
Also, Ash, could you just zoom in like a couple bips? I think I'm seeing some comments about that.
Zoom in.
Just like Command Plus.
It's not working. Let me see if I can do it this way. Okay, my Command Plus is not working for some reason. Sorry about that.
No worries.
So guys, talk through what's happening right now after you ran the command.
So it created a notebook for the actual labeled scenarios. And the notebook is essentially going to be our location where we have the eval running on top of our agent for Ask Acme. So in this scenario, what we're doing is I compare what a golden set is versus labeled scenarios. You'll notice a golden set is 10 to 50 curated cases. This is the first step you should be taking with your product manager and your expert. Then what you're going to do is create 30 to 100 labeled scenarios. Some are failure states. Some are like different based on categories and releases. And then some are coverage gaps that you might have missed when you created the golden set. Now, people always ask me this question, so I want to preemptively answer this. Is the entire point of an eval system just having a human continuously create scenarios and test and actually make them run? And the answer is yes. Like your expert, your product manager, your engineer is going to hate you a little bit. But the result of what you're going to be doing over the 3, 4 weeks, 7 months, so on and so forth, is going to be something that is so much more robust, repeatable, and like people are actually going to be able to get real value from it. So yes, this is the tedious job of like walking through every test case scenario, actually annotating it, actually being thoughtful about what the input and output pairs are going to be. So the answer is pretty manual right now. Okay. The only difference between a golden set and a labeled scenario is you've categorized them and you've annotated them, meaning you know the exact tools that are going to be used, you know the exact topics that are going to be covered, and then you try to have coverage across all those topics. So what does this look like? If I have a travel agent, right? And I keep going back to this because it's a project we recently worked on, and you have to cover booking hotels, flights, rental cars, then you can have labeled scenarios in all 3 of those categories. You can have golden sets within each of those categories, and you can run those evals across all of those sets. The thought process is that you can actually showcase coverage when you analyze this data across all your test scenarios and test suites. When you have this level of sort of robustness, the likelihood of something going wrong or an edge case coming up that you have not yet handled is much lower than a golden set. In a golden set, you're tightly decoupled to the most common queries that are coming in. In labeled scenarios, you're saying, okay, these might not be the most common, but I'm going to increase the database of values.
And so just so I understand here, like an example, just going back to the travel agent, like one part of a travel agent may be like, I don't know, excursions. Like I want the travel agent to book me excursions for my trip in Greece as an example. And potentially in the golden set, there could only be one question in that golden set or 2 questions about excursion where it's like, what's a good excursion for me to do on this trip? Whereas are you basically saying with kind of this labeling and categorization, there could be a whole set of questions related to excursions where I could potentially ask, like, given my budget needs, given my bias to adventure, given I'm going to Greece, what is a good excursion for me to do?
That's exactly right. The query becomes more complicated, Alex, as you sort of gave the example of, but it's also like you're expanding your test cases across the board. And so you're handling edge values that you might have never thought of.
Cool.
Okay, I'm going to keep going because of time. This actually runs through the entire labeled scenario thing. You'll notice that it has a very similar flow to what a golden set is. It's just more comprehensive. And the thought process behind labeled scenarios is you have almost a library of everything that you want to test for your AI system. And in this scenario, the library is maybe just like company related questions that are delineated by job title, by source, by whatever somebody might be asking. But if you're thinking about Claude Code Manus, this library can be massive, right? You can have labeled scenarios for Python when trying to create an API using Fast API. That could just be a sliver of all the test cases that you have. You want to make sure that your system is sort of having coverage over all the possibilities for a user on top of your platform. Okay. Next one is going to be, and I'm just going to close this out. It's going to be our replay harness. So we're at the point where now we don't have enough time as human beings inside of these companies to continuously do this over and over again, right? We have to sort of focus in on other aspects and make sure that we're able to do this at scale systematically. And that's where something called a replay harness comes in. So the thing that happens when you're building out these eval sets is you have a specific scenario in which you have this input pair and this output pair, and you're trying to figure out what went wrong. And when you're trying to figure out what went wrong, it's really hard for you to replay exactly what went wrong. What a replay harness does is it records that input output pair. It saves that exact tool call set, the sources that were used, the input values, the system prompt, so on and so forth, and the output pair. It allows you to replay it using a cached prompt so that you can change aspects of the prompt and see if it would function much better. This is essentially like saying, if I had instant replay on all the plays that I was doing for basketball, or like for the NBA, I want to do that for my AI system. So I can replay this scenario where Alex put this question in and it didn't give a good answer. Well, what can I do to adjust that scenario to make sure it does give a good answer? And that's what a replay harness is. So let's run that really quickly.
And as you're running this, what it makes me think about, I don't know if this is the right way to think about things, is it's basically turning models which are probabilistic to be quasi-deterministic. Like you're basically giving it as many deterministic rules as humanly possible, which I guess like at our core as humans, a lot of the thing we have these embedded rules that we follow. And of course there's nuance and taste where we kind of go off script, but there's this massive library of rules we're just following based on previous experiences. I don't know if that's the right way to think about it, but like it seems like you're just adding a ton of determinism to a probabilistic model.
That's exactly right. Like my goal as the engineer, as the designer, is what can I do to make the lives of the humans that are annotating and making sure that this system is performing well easier, right? So if I give them this replay capability, if I let my product managers come in and just retry all of these different scenarios, then they not only can give me better feedback, but then we can also test and see if the iterations that we're making actually make a difference. So that's exactly right. I am making an inherently indeterministic system deterministic, or trying to at least. Okay, so this is my replay harness. And again, each notebook sort of walks you through what the problem is, what it means, what it's trying to do. In this scenario, stage 1 and 2, those were live agent calls. I was actually calling my Ask Acme agent. I was using variable results. I was trying to see if it was a simple pass fail checklist criteria. When you start having a replay harness, you can actually start caching responses. You can have a deterministic way to test your system back and forth, which means you can have numeric values or scores associated with different checkpoints of your system. And you have the ability to continuously replay and see if those scores go up and down if you change the prompt, change the tool, or change the model you're using. So in this scenario, what's happening is I have something called a record function, which is taking a session, hitting the actual agent, and recording the actual interaction. That's being saved in a JSON object inside of my repository. This can be saved inside of your observability platform or a database, but I'm trying to keep everything containerized within the example I gave you. I'm having a human come in and annotate it, meaning I can have the human edit the relevant sources. I can have the human edit the different keywords it should be looking for. I can have the human come in and edit the prompt. And I can replay the same query based on the same values with the new configuration by the human. Then I can see whether the precision, the recall, the groundedness, the faithfulness, these are things that we've heard of, which I'll talk about in a second, go up and down. These are numeric values that we're associating with the performance of the agent. And all we're doing is delineating changes to that replay to see if those values go up. I am basically giving you with replay harnesses a test environment, a staging environment where you can test your system back and forth to see if it actually improves. Does that make sense so far?
Makes sense. And just to understand here, in this like replay step, my understanding is the human is still required in the replay step. Is there a point where you abstract the human and the LLM? Is that where it becomes LLM as a judge, where LLM is the stand-in for the human doing replay?
That's exactly right. So
Got it.
Up until this point, we're basically decreasing human intervention, That golden set is like completely all human. Labeled scenarios, like you can actually synthetically generate some things or actually group things together or have an LLM help you out there, but it's mostly still human. In replay harness, it's much less human, right? A lot of this is just the numeric values that are running back and forth. And then the human is just coming in to make tweaks. Next step, which is rubrics, are like even less human, where you have the human build the rubric, use that to calibrate the LLM as a judge, but the LLM is the only one that is actually making the determination. Okay, last couple of things, because I don't know where time is going to put us, but precision, recall, F1 score, MRR, faithfulness, groundedness, completeness, relevance. There are so many numeric values that you can use to judge an LLM system. In my opinion, try to pick and choose 2 or 3 to start out for your replay harness. And this should be solely based on the failure state of your AI system. We do a whole nother session at Gauntlet for this, where we try to say, like, in this version of a RAG pipeline, what are probably the best scores to use? Or in this version of an agent, what is something that you should keep in mind? When it comes to retrieval, always think of precision and recall. Precision is the number of vectors that you've retrieved, and of those vectors, how many are actually relevant to the answer. Recall is the sort of coverage across your entire vector database of all the topics that you might have. When it comes to an agent, always go for your tool, call, eval. Like, does it call the right tool at the right time? That is by far the best eval for an agent. And the other evals for an agent could be completeness or accuracy, sort of like an end-to-end eval, whether it actually completes the job. If you start there, you're 80% of the way there. You know, if you're trying to get lost in all of these different scores, then it's going to be like you have all these scores that kind of mean nothing. And so for that, I try to focus on the 2 I gave you for each of those categories. Okay, I'm going to run these cells, and then we're going to move on to the next one because of time. Any specific questions that I missed?
Yeah, this is amazing, Ash. I've learned so much during this conversation. Few questions, and you don't have to answer them all right now, but just so you know, questions that are being asked. Yeah. One is, Daniel said, most models aren't trained on tool calling, or is that changing? That's one question that someone asked. Let's see what else.
So models aren't trained on tool calling, but they can still do tool calls inherently. Does that make sense? I don't know if that kind of made sense, but like when you tell an LLM, hey, these are all the decisions you can make, and the LLM comes back with maybe a JSON object and says, oh, go back to this XYZ agent, it can inherently make that decision without having been trained on tool calls. So any LLM can be used for tool calling, is what I'm trying to say.
Yep. Awesome. I think we're good on questions for right now. Let's keep running through. This is great.
Okay. All right. So that was our replay harness to give you a sort of replay environment on how to walk through each of the cached versions of your different prompts. The next stage is going to be rubrics, and it's by far this is the stage you kind of want to get to, because when you get to this stage, you can scale your eval system across hundreds of thousands of records, hundreds of thousands of users, and still get some level of indication or signal on whether or not you should improve that system. So I'm going to go back to my cursor for a second. And again, I'm just walking through each of these notebooks in this scenario. But again, if you want to walk through this just programmatically, you can do so as well. We're going to go to stage 5, the rubric. Where is it? Stage 5. Oh, stage 4. And we're going to do the same notebook run again. Okay, I'm going to switch my screen out to this walkthrough. Okay, rubric-based evaluation. There are large groups of individuals in the Philippines and South America, across the United States, that are just annotating records from LLM interactions. This is a real thing that is happening. There's multi-billion-dollar businesses of experts annotating different input-output pairs. When you're trying to do this, the thought process is you have your expert, and your expert helps you create a rubric. And the example I'll give is, I have a director of learning. His name is Byron. Byron has all of the learning down to a T. He knows what learning science actually means. He comes in and he builds a rubric that is a grading system for a project that we might have. It grades the individual based on completeness, their code quality, their architecture, their design, so on and so forth. We take that rubric and we have this initial input-output pair. And what we're doing is we're saying, hey, Byron, can you go grade this? And then we're telling an LLM, can you go grade this? Then we're taking the results from that rubric from the LLM and Byron and deciding what the discrepancies are. Why is it that Byron grades things a certain way here, but the LLM doesn't grade things the same way? You want to calibrate your LLM judge to Byron, because Byron is a subject matter expert. He understands what's going on, and he is going to be the source of information and the source of truth. Once you've calibrated based on this rubric, your LLM as a judge to your SME, you are now ready to scale that rubric and that LLM. Because now what you're going to do is you're going to now run that same rubric, that same model, that same prompt across hundreds of thousands of records, and you'll get scores across the board. But what people miss about this rubric step is that the human is only involved in the beginning of it, in the calibration point. And yes, every 7 days, every 2 months, I have Byron come back in and make sure that, hey, this is still calibrated to my liking, but I am just continuously running this back for my entire AI system. So in a nutshell, that is what rubrics are. And again, because of time, I'm going to go a little bit faster here, but your goal is LLM as a judge. Train the judge to be good as the SME. Okay, for this last part, I'm going to probably just do this sort of off the cuff on the riff because of time. But the last part are these something I like to call experimental configurations. And this is the last stage inside of the repo. These configurations are almost like A/B testing a funnel, right? When you have a funnel, that funnel says, oh, these are the top of funnel from Google Ads, the top of funnel from Facebook ads. And then you come all the way down and you realize, hey, these are different parts of the funnel that need to be updated. When it comes to your AI system, the vector database you have, the model you're using, the embedding function, the retriever, the agent, the orchestrator, the graph, the framework, this all makes something called an enterprise configuration. This configuration is going to be, let's say, the baseline judge of what's actually happening. And you can make several different configurations that you can compare and experiment against. So you want to almost treat this like sort of like a data science experiment. So the newest version of GPT-4, GPT-5 came out. Well, you're just going to switch out that one variable, switch out that model. You're going to run your eval set on top, and you're going to say, oh, GPT 5.2 works way better than GPT 5 when it comes to my AI system. So what is the end goal? Like, what does production eval systems mean? It means you have experiments running in conjunction across different configurations of AI tooling, libraries, software, models, prompts, so on and so forth. and you're running your eval set across all of those configurations and making a decision as to what the best thing to expose to your user is.
This is a meta question, but like, to me, it's like, what is the human absolutely needed for in this whole process? What comes to me is like the insight from the subject matter expert that the model doesn't have. It is like user centricity at like the product level, but everything else, it feels like the model can figure out. Is that like a good assumption, or am I kind of not looking at this in a nuanced enough way?
No, I think you're right. And that's not to say that the model will always have it right. I think it will drift.
Yeah.
So you always have to bring the human back in to recalibrate it to sort of make sure it's using the rubric correctly. But you as the human being are the person that is directing the model. You are calibrating the model. You are deciding what the model should look out for. You're making sure that it's performing at the level it should. But everything else, from the generation of the code to the iteration of the prompts to the actual judging, can be done by the LLM.
Awesome. One last question I have for you, and then Armand, feel free to bring us home, is I know some folks are probably going to wonder, like, what is your ideal stack, like your ideal tech stack that you use to build agents, to run evals? Like, what is your AI stack? Feel free to share kind of like your preferences.
Like my coding stack or like my building with AI stack? You know what I'm saying?
Building with AI.
I love Mongo as my vector database. Usually Python is going to be my primary language of choice. TypeScript is catching up, but I do think the best, like the libraries and the methods in the Python ecosystem, are still the best. I like to start off with an agent framework like LangChain or AI SDK. But then what I like to do is to take that framework and just remake it by myself using Claude Code. So the initial, I'll use a framework, but eventually I'll make it myself. In terms of what I got, the agent framework, I got the vector database, the retriever. I'm just basing that off of the connection to the vector database or building out my own. In terms of my model, I'm always starting with OpenAI. And then in terms of my embedding model, I'm always starting with Ada 002. I'm changing that in a configuration when it comes to the enterprise stack. But until then, I'm just going to stick with OpenAI because it's honestly the most reliable when it just comes to uptime. And then finally, in terms of like the generation steps, for each configuration, I like to keep the same model. And then every time I try to make a new configuration, I switch the model across the entire thing, because I kind of think that the prompts, the embeddings, the retrieval, the decision-making, and the prompts, like the system prompts themselves, all sort of kind of are conducive to the same ecosystem.
Love it. Awesome.
Yeah.
Armand, feel free to bring us home.
I have two questions for you.
Yep.
One, I am a pessimist when it comes to words that I see on Twitter too much. So early on, when MCP started coming out, I was like, this is a load of garbage. This is bullshit. This is just another, like, you say MCP and VCs start writing you checks. Like, it's literally just a tool call wrapper on a API call. Like I'm a caller of bullshit, and I'm a pessimist.
Yeah.
I'm a pessimist about evals.
Yeah.
Why? Because it's just testing.
Yep.
Right. It is the way that I think about it is like, to Alex's point, it's you have these probabilistic models. You want to put some guardrails on them. So you're going to like create some testing that can manage probabilistic models. I think that that's kind of what I take from it. I think the reason why people talk about it so much is because we've all spoken to enterprise, or like on this call, the three of us have spoken to enterprise customers, C-suite executives at enterprises, and we've talked to VCs, and we've talked to naysayers about AI, and evals are a really easy answer to people when they are negative about AI. And so I think it's like, okay, we know we have this tool. If people are questioning us about hallucinations or inaccuracies or whatever, you say evals and it shuts them up. And I think that's why the word evals is so common. I don't think you agree with me. I think, after sitting here for an hour with you, I think that you see evals as a tool to help an engineer build an agentic system. Is that right? Like, how do you... I think you disagree with me. Explain why you disagree with me on that.
So I don't think I disagree with you completely. Do I think there's a ton of bullshit around evals? 100%. I think there's a lot of like hype oftentimes too much information regarding specific areas on evals, especially on Twitter. And like, there's this whole like feud and, oh, you need evals for Cloud Code. You don't need evals for Cloud Code, blah, blah, blah.
Yeah.
But do I think that us as engineers will always need a systematic approach to testing? Yes. Will we always need a systematic approach to the creation of iteration, the creation of these AI systems, and some sort of thought process or diagram or design principles on how to test these systems? Yes. Are we maybe just taking old school software engineering principles, renaming them, and now using them for AI? Maybe. But do I think that they're going to be this, like the real unlock for huge multinational companies that finally realize like, hey, with proper testing, anything is possible? I also think that is true too.
Yeah. Okay. So last question. I'm with you there. Last question. Alex and I have literally been DMing on the side here about how incredible this has been. Like, you killed it. You have a whole structure here. It is no wonder that you spend your time teaching people about this. I want to make sure that people understand how they should get the most out of it. And as an example, I would compare this to the Andrei Karpathy YouTube videos on AI, right? And by the way, people, if you have not seen those videos, I recommend you do that. I've recommended, like when Alex and I first started talking about like upskilling in AI, right? I told him like, hey man, I think you should go watch Andrei's videos. And I think that you should literally, this is what I did. I had a notebook and a pen. Yeah. And it was like I was in a lecture. I was taking notes. I would pause. I would prove the math. I had a Jupyter notebook and I was writing the code letter by letter to make sure it was sinking in. I was running it. Like, that's how I went through Andrei's videos. So a 2-hour video took me 2 days to get through. How do you recommend people go through this video?
I think for me, hands-on keyboard is by far the most important thing when it comes to my repository. So I don't want you to just watch me. I want you to actually try to break what I've built. Because if you can try to break what I've built, see some of the errors associated with it, because I'm sure there's something in there. The goal should be that you're running this on your own. You're walking through each step of it. You're disagreeing with aspects of it. You're editing aspects of it. You're having Claude Code teach you aspects of it. And the amount of time you sort of do hands-on keyboard with it, yeah. The video should come in where you feel like you almost disagree with my perspective, or you think, oh, this doesn't make any sense. Let me go see and hear what Ash is saying. So obviously, I'm guessing they'll get a transcript and the whole 9 yards. But the long story short is, let's say you're going through your labeled scenarios and you're like, okay, I want to see what Ash said. You can go back and go back into continuing to do what you're doing. I also think you should take my repo and try to recreate it with your own example. If you're able to do that, you've pretty much ingested everything else. So those are my 3 big tips. Hands-on keyboard is key. Try to break things, try to change things, manipulate things. 2, come back to the video when you have key aspects that you need clarification on, maybe using the transcript. And then finally, try to clone and replicate my repository for your own AI system. Because cloning by far, and this is like a Gauntlet tenet, by the way, is like the best way to learn something.
You're muted, Arman.
Like, am I?
Good now. You're good now.
Okay, cool. Like I think that ultimately when people look at sample code, a lot of times they treat it as precious. And I think it's actually really important. Like, delete a line of code.
Yeah.
See what happens. Add it back. Delete a letter. See what happens. Like, beat it up. Like code is clay and you have to play with it like clay. And so I think I agree. Like if I were to go through this again, I would watch the video from scratch, not touch a thing. Then I would look at the repo and I would download the repo. And like you said, just play with it, beat it up. And I'm seeing questions about where will the recording be? The recording is going to be on YouTube and we're going to link to everything in the show notes. And yeah, I think it's going to be an awesome resource.
We send the recording to everyone after who register for this. So you'll be getting it before it goes on YouTube. And just from the non-engineer's perspective, my plan is to go through this as well. And it'll just look a little bit different, which is I'm going to fire up Claude Code and I'm going to basically have Claude Code walk me through going through this repo step by step. And in doing so, it's going to basically be as if I have Ash or Arman looking over my shoulder, rebuilding this agent.
You want Ash over your shoulder. He's going to be much more knowledgeable. I'm going to be a bit of an asshole, so you don't want me over your shoulder.
This, Ash, this was amazing. Thank you so much for taking us through this. Like, I think, again, like Armand said, like in the Twitter zeitgeist, evals are talked about a ton. And I don't think people actually know what they mean. And they kind of feel like witch magic to people. And I would say this is the first time that I actually have some level of clarity around what they mean in practice. And so I'm excited to just like actually, and they also feel like they're such a core piece of building agents. And because I didn't understand what the evals were, I wasn't sure like, how can I build an agent? So it almost feels like a missing piece of the puzzle. So I think this is awesome. I can't wait to fire up the repo. And I think people are going to get a ton of value out of this. So we really appreciate you.
No, evals are more like an art form, not like hey, this is the exact way to do it. So like, please try to break my thought process. Send up some PRs. I'd love to give feedback. And thanks for having me, guys.
Awesome. Thanks, Ash.
Thanks,
and
Ash.
thank you everyone as always for joining.
See ya. Bye.